We continue with the same problem, but in this lesson, let's find the maximum height to which the projectile rises as measured from the ground. We can divide the trajectory into two parts, from A to B, where B is at the same horizontal level as A, and from B to C. To find the maximum height, we must use the fact that the y component of velocity at the very top would be 0. As we have seen, the y component of velocity decreases from A to the topmost point, where it goes down to 0 and then increases again on the way down. Let's plug this into the first equation of motion along the y-axis. So we have the final y component of velocity at the very top as 0. The initial y component of velocity at the launch point A is 70 times sine of 30, and the acceleration is minus 9.8 as it is pointing in the downward or negative y direction. From here, we get the time taken from the launch point A to the topmost point as 3.5 seconds. Can we find the height from here knowing the time that it takes to get to the top? Again, we are focusing on the y direction. We choose the reference line at the top of the tower and we apply the same sign convention as in the previous lesson. Now we will use the third equation of motion, so Vy squared equals V0y squared plus 2a times y minus y0. The final velocity at the topmost point is 0. The initial velocity at A, the launch point, is 70 sine 30 and is positive since it is in the upward direction. The acceleration is minus 9.8 since that is in the downward direction. The final displacement is h as measured from the reference line. This is important to note that it is measured from the horizontal line passing through the launch point. It is positive since it is upwards from the reference line. The initial displacement is 0 since that happens to be on the reference line. With this, we obtain the maximum height h as 61.25 meters. Now, we could have also used the formula for the maximum height of a projectile that we derived some lessons ago, which was V0 squared sine squared theta over 2g. And here also we would have got 61.25 meters. But remember that this is also from the launch reference line, not from the ground. So we are considering only the first part of the trajectory from A to B. But now we are asked to find the maximum height from the ground level. To find the maximum height attained from the ground level, we need to add the tower height to the maximum height attained by the projectile from the reference line, or capital H. Since the height of the tower is 100 and h is 61.25 as computed, the maximum height from the ground would be 161.25 meters. To compute the maximum height from the ground, we make use of the concept that at the very top of the flight, the y component of velocity of the projectile would be 0. And from here, we obtain the time it would take to get to the topmost position using the first equation of motion. To compute the maximum height, we use the third equation of motion and obtain the maximum y displacement from the horizontal line passing through the launch point. The total maximum height from the ground level would be the tower height plus the maximum height from the launch level.